What's up, everybody, and welcome back to another float video. This is Jacob Tucker, and in today's video I'm going to be showing you how to sign a message on a backend and then verify that signature on chain, and also explain what all of that means because it's probably really weird and confusing. So welcome to another video. Also, for the record, my left eye is super pink, so if I look like a freak, don't make fun of me. Freaking legend, you know, had to dab on that one. Sorry. Okay, I apologize. Anyway, let's get right into the video. So what do I even mean by all of this? What does signing mean? What is a message, private keys? What does verifying mean? I'm going to explain that today. So what we're going to be doing today in code is we're going to be what's called, signing a certain message, which is basically just some data, and then verifying that that signature came from the account that signed it. So in order to understand what that means, we need to understand public and private keys and, like hex strings and all that kind of stuff. So what I have here is a diagram. There's two parts. There's the signing part and there's the verifying the signature part. Now, for signing, we're going to start on the left-hand side here. So, every account on the blockchain has a public and private key pair associated with it that's inside the account. So, an account can have many different public keys, but let's just narrow in on one public and private key pair inside an account. Now, when you generate a public and private key, they're paired. A private key is associated with a public key, and a public key is associated with that same private key, right? They're a pair. Now, how signing works is you take some sort of message or some sort of data. Now, in this case, the message is Jacob is cool. And what we're going to do is you take your private key and you sign that message, which produces what's called a signature. Now, the cool thing about this is that, when someone signs a message, you have proof automatically that if you have a signature that came from a certain account, you have proof that that account owner is the one that actually signed it because it requires their private key, right? I can't sign a message on behalf of your account because I don't have your private key. So it's a really secure way of knowing that some account, signed a message or knows that something is happening. But the cool part about it is that in order to actually verify that that signature came from that account, you can use the associated public key to verify it. Now, this is really cool because, the account owner can keep their private key safe and secure and private and sign the message, but then I can use your public key, which everyone knows, to verify that you used your private key to sign the message, right? So it's a little confusing, but just bear with me for a second. So in order to actually sign the message has to be what's called a hex string. So if I narrow in a little bit, I don't even know if I can do that on the screen, but let's just try. Yeah, so you'll see that this hex, this is a bunch of like random letters and numbers. Well, when you actually sign a message, you're signing the hex string version of that message. So in this case, the message is Jacob is cool, but we convert it to a hex string, which is a bunch of letters and numbers, and then we use our private key to sign this message, which produces this signature. Now, the cool thing about a signature is that the produced signature, which is this green letters and numbers right here, that depends on, number one, the message, and also the private key that signed it. So you won't be able to produce the signature if either the message or the private key are different, right? So it is pretty, secure, and you can know that, you can't replicate it, right? Now, on to the verifying part, the verifying thing does two things. Number one, it verifies that the account is actually the one that produced the signature. So like I said, this signature would not be the same if it was from a different account or a different private key. So, it's cool because, we can verify that that signature actually came from some sort of admin account or some account that we're expecting. Now, number two, it also verifies that the signature comes from the hex version of the message. And what I mean by that is that, we can take the signature and make sure that this signature was produced from this message, right? That it didn't come from Jacob is terrible or Jacob is bad. It came from Jacob is cool. So we can verify both of those things. And again, we can use the public key for that. So we can do public key dot, call some verify function that we're going to go over, and then pass in the message and signature, and that will verify. Again, this is sort of like the one-liner. It will verify that the signature was produced by this account, signing this exact message. So that's what we're going to do in code. Let's jump into code. Now, I actually this is all in my GitHub. So I'm looking at my GitHub right now. I actually already coded all this out because I actually recorded this video and then realized the format was wrong. So it all got to waste. It's so annoying. But I'm going to go ahead and just delete a bunch of things here because I want to start from completely fresh. So what we're going to do, so I basically just emptied everything. The only things I have here are the README, which is for the GitHub, a package.json, whatever, and then an empty main.js file. So let's delete this as well. Flow.json. Now I just got this flow.json by just typing flow init in the terminal. You don't need this or anything. And then a config.json. So the config.json is where I'm storing my public key, my private key, and my address. Now I generated these before the video even started. So if you need help, generating your own testnet account, I made a video on it. Definitely go watch that and check that out. But yeah, I made a testnet account before this video. Now also disclaimer, this isn't like a testnet account I actually use. So if you know this private key, you can't do anything with it. So if you were going to try and hack me, middle fingers to you, but it doesn't matter anyway. Okay, we have an empty main.js file. Now what we're going to do is I'm going to define a function called doStuff, just like this. And after this, I'm just going to call doStuff. Now we're going to put all of our logic inside this function. So what this is going to do, for example, is that if I just console.log like hello you idiot, then then if I go to my terminal here and do node main.js, it's going to run hello you idiot, right? So it's just going to run whatever is in this function. Okay, so the first thing that we're going to do here is we're going to come up with a message. So the message, and this could be any message that you want to sign, right? So whatever message you want to sign, let's say the message is Jacob is cool, right? Just like that. So this is the message that I want to sign. But if you go back to this sort of diagram here, let's actually open up the diagram again. You can see that the message that we want to sign is Jacob is cool, right? Which is exactly what I put right here. Awesome. Now, the next thing is that, there's we need to actually make this a hex string. So when we're looking at this, we're not going to actually sign Jacob is cool. We're going to sign the hex version of it. So we have to convert this, string to a hexadecimal string. And the way that we do that in JavaScript is by saying buffer.from. So we put it inside of a buffer, and then we do .toString, and we put in here hex. So this is going to convert Jacob is cool to a hexadecimal string. Now we can even look at that. We console.log the message. Let's take a quick look. Let's see. So if I run node main.js, it logs 4A616, which is exactly what I put right here, right? Wow, I'm just such an incredible teacher. But anyway, that's what's right here. Okay, cool. So that's the message, right? Now the next thing we want to do is we actually want to, sign the message. We want to sign it with our private key. So what we can do is we can say const sig, which is the produce signature, right, from signing, and let's call it a certain sign function and pass in the message. Now, in order to do this, we need to include some complicated signing function. So in order to do that, first go into your terminal. Let me increase this for a second, just clear everything. Do npm install @onflow/fcl @onflow/types elliptic and then SHA-3. So these four things. Let me just expand this so maybe it's easier to read. @onflow/fcl @onflow/types elliptic and SHA-3. I've already done this, so I'm not going to do it again, but make sure to do that. Now when you run that command, the reason that we're bringing in FCL and types is because we're going to actually verify the signature on chain, and the other two are for the signing function, which I'm going to go over now. So what I encourage you to do is this exact GitHub is going to be in the description. Go to the description right now, click on the link to this GitHub. It's going to say source code. Click on that link and click on main.js. Now, what I want you to do is, as you know, if you've watched my previous videos, I hate when YouTubers copy and paste code because it will confuse you. But I really encourage you to copy and paste this code because it's confusing, and if you try and type it out yourself, you're probably going to type it in wrong. So not trying to be an a-hole, but just go from line 23 and up and copy all of that code and go back here and paste it. Now the reason I'm telling you to do that is because that's going to import some stuff, and I'm going to explain this, of course, but let me just copy paste that for now. So we're importing these lines. This is just importing FCL and types. We're only going to do that to verify our thing on chain. I'll show you that, in the later part of the video. And these three lines right here, this is where things get a little tricky. So we're importing SHA-3. We're going to need that for our signing function. We're also just doing this random line, which gets EC for us so we can use it in our functions down here. And then this is where things will get different depending on your key. So the address or the account that I'm using for this video is this right here, this address. It's I actually pre-generated it before the video. So let me open it up in the view source and explain to you a little bit about keys so that we can go on with the next part of this video. So when I generated this account, it gave me this key by default. Now you can see that this is the public key that's associated with this key, right? 972C1D, right? 972C1D. So that's the public key. And the private key, obviously you can't see, right? Obviously I can see it because I'm the account owner right here. And this is the address, right? So if you take a look at this, you can see the key ID is 0. It has weight 1000 of 1000. I'm not going to go too in depth on that. But what's important to note is this part, the curve. Now you'll notice the curve is ECDSA underscore P256. This may be different for you, depending on what key you want to use to sign your message. You can use any key you want. I think the weight has to be 1000 out of 1000. I'm not sure. But anyway, your curve might be different. Now this is the signature algorithm. In my case, it's ECDSA underscore P256. In your case, it may or may not be this, or it could be ECDSA underscore SecP 256K1. If it's that one, no worries at all. I'll show you how to do that in the video. So just look right here. Now, if you have P256, make sure to type P256 right here, and then I just call this like ECP256, right? If you have the other one, type in SecP 256K1. Now, and then you can, maybe rename this one to EC, SecP 256K1. I don't know, something random. And then that way, you'll take this variable, and in your sign function, you'll put that right here, okay? So you'll put that variable right here. Now, in my case, because I'm using P256, I'm going to go back to the default, which is this one, and then this right here is ECP256. But, whatever variable you put here, put right here as well. Now, the next step is to replace this string right here with your private key. So in my case, my private key is 0603982DE, which is why I put my private key here. You should put your private key here, or a more safer way is to make it like a .env variable and then import, the env variable here so you keep it secret. And remember, never ever push your private keys to GitHub or anywhere. That's really dangerous, right? So don't do that. Now these parts, so this right here, fcl.config, this points our application to testnet. So if you're on mainnet, you want to change this to mainnet.onflow.org. This is, like I said, we're going to be using FCL to actually, verify our signature on chain. If you want to verify your signature on mainnet, make sure you do mainnet, but in this case, we're using testnet. And then these two functions right here are used to sign the message. So I don't even really know what they're doing, so I'm just going to skip that part. But you'll notice that down here, when I wrote sign, it's using this sign function now, and then sign function is using hash. It's a helper function, so don't worry too much about that. But here we are, right? So cool. Now, the next step here is we actually want to, you know what? Let's just take our signature and console.log sig and see what happens. So if we run node main.js here, it's going to throw an error. Ooh, okay, cannot find module at onflow. So I think that's because actually maybe I need to re-npm. Maybe I do need to npm install that. So npm install onflow's fcl onflow/types. You've already done this, right? SHA-3 and elliptic. So I guess I just have to do this for some reason. Oh, it's because I deleted my node modules. Oops. Anyway. So you've already done that part, so don't worry about that. And then run node main.js. Now you notice here's the message, and then here's the signature, right? So OC75, I'm pretty sure it's also what I put in the diagram. I can't remember, but it doesn't matter. So anyway, this is the signature that gets produced. Now if we go back to, let me just open this up in a new tab so we can keep looking at that diagram, because I think it's really helpful. Let's go back to the diagram here. Yeah, so now look at what happened. We had the message, Jacob is cool. We converted it to a hex, right? So that's what's getting printed right here. That's the hex. And then the signature that's produced is this long green thing, right? These letters and numbers. And that's the signature that we're seeing right here. So this signature, was produced by our account, by our private key with that specific message. Now, look, if we were to change the message for some reason, right, and just change it, you'll notice that the signature is going to be completely different, right? It's totally different now. So that's really important to know. The signature relies on not only the private key, but also on the message, right? So you can't duplicate a signature. Yay. Okay, here we are. So the next part of this video is going to be going over how to actually, verify that this signature came from our account and from the message that we thought. So to do that, let's open up a new script here. Let's just call it verify.cdc, and this is going to be a Cadence file, and we can actually open up it. We can start doing some script stuff. So we're going to make a script, public function main. It's going to return a Boolean, and it's going to say like missing return statement. So to get rid of that error, let's just like return true down here, and all should be good to go. Now we're going to need to pass in a few things here. The first thing we're going to have to pass in, this is all for memory, by the way, so hopefully I get this right. But the first thing we have to pass in is an account address. So this is going to be an address, and this is the account that we think is the one that is you know, that we think is the one that signed the message. So if we go back up here, let's just say, you know, account address is the account we think signed the message, and it will verify whether or not that's right. Now the next thing is the key index. Now this is an integer, and the key index, this is the public/private key pair that was used to sign the message. Now, in our case, if we go back to the view source, we're using this public key, which has a key ID of 0. So this is the key index right here, 0. That's what we're going to pass in. Now, again, an account can have many different public keys or many different private keys or just keys in general. And, you know, whatever key you're using, you have to use that key ID. All right. And then the next thing is going to be the SIG. So the SIG is a string, and then the data or the message, which is a string as well. So we're going to pass these 4 things into the function. Yay. Okay, now the first thing we're going to do is actually get the account. So we pass in an account address here. Let's get the account from that. So let's say let account equals get account, and we're going to pass in the account address. All right. So now we have the account. Now that we have the account, let's actually get the key that's associated with this key index. So let's say let account key equals account dot keys, and I think, oh god, dot get, and then I think we pass in a key index, which is just a key index. Now what this is going to do is it's going to look at the account, get all the keys, right? So it's, you know, if you have a list of keys here, it's going to be all these different keys, but in my case I only have 1 key. And then it's going to say dot get the key that has this key index, right? So in my case is 0. So when I pass in 0 here, it's going to return this key, right? It's going to return this key right here, this whole thing. Now, because it's returning this whole thing, we actually want to get the public key specifically. So that's why we do let public key equals account key dot public key, and that will rip out this public key right here. Now, this is really helpful for us because that allows us to then we can call functions, specifically a verify function on this public key to verify that you know, this message and signature were from this public key. So next, let's just say let sig equals sig.decode hex. So the reason we have to do this is because when we pass in the signature, right, it's a bunch of random letters and numbers. But the verify function on the public key actually is expecting a array of uint 8s. So we have to decode the signature here, and the same for the message. So let message equal message.decode hex. So same exact thing, we have to decode both of these two. Now the last thing we have to do here is return. We have to return, public key dot verify, and now we have to pass in some information to this verify function. Now, because I'm, you know, a trash YouTuber and sort of forget this part, let me actually go to my script here. Okay, so we need a few things. We need a signature, a signed data, a domain tag, and a hash algorithm. Okay, cool. So the first part is a signature, and that is the sig. So we're just going to pass in the decoded signature. Now the next part is the signed data, and that is the message. So the, you know, data that we signed was this message, right? We were signing this message which produced this signature. So this is the signed data right here. Yay. Now the next part is, this is where things sort of throw me off, honestly, is the domain separation tag. So it's called domain separation tag. Now this on Flow is not too important. Honestly, I wouldn't even spend too much time thinking about it, but it's basically a tag that should automatically, or keep in mind should, that's an important word, be automatically prepended to every signature to verify that it's actually from an account, all that. So it's always going to be whatever this is. So let me just copy this for a second, because I don't even know it myself, but it's flow-v0.0-user. Now, again, this is just some random thing that automatically gets put onto every signature to verify that it's correct. And, you know, we'll see how this is going to cause problems in a second here. Now, the last part is a hash algorithm. Now, the hash algorithm is always just going to be hash algorithm. Now, keep in mind, this is with a lowercase h, and this is an uppercase h, dot SHA-3, 256. So you're always going to put SHA-3, 256 here, just like that. Or I mean, like 99.999% of the time. All right, yay, that's awesome. So now that we have that, we're returning the public key here. Perfect. And now let's, so let's go back to our file here. So let's now verify using this script that this signature came from this message from the account with this private key, right? So let's just run a script. So we've done this a billion times in other videos. const response equals await fcl.send, and this is why we imported fcl and end types. fcl.script. Now the script code is going to be literally just this. So let's get our script, put in our script right here. Alrighty, we're going to say fcl.args. We're going to pass in some arguments here, and this is where things get a little complicated. So the account address we're passing in, well, this is the account that we think signed the message. Now in our case, we obviously know it was me. Now this private key right here belongs to this account, right? This account that I was showing you, this account address. So what we can do is we can actually take this account address right here, go back to our main file, and we can say, const account address equals this account, just like that. And then down here, we can say fcl.arg, pass in the account address, say t.address like that. And that is the account that we think signed the message, right? Which we obviously know is right. Awesome. So for the next part, we need to pass in the key index. We need to say fcl.arg. We need to pass in some sort of key index here. Now we can just make a variable called key index, and what is going to be the value here? Well, in our case, we're using this public/private key pair to sign the message. So the key ID is going to be 0, which is, it's literally just showed you right here. Now, if you have a different public key and the key ID is separate, make sure you put that key instead, but this is 0, right? So let's just put 0. And now we can go ahead and pass in the key index right here. And the type is a t.int. All right. So the next two parts are going to be really easy because we already have the signature and message, right? The signature is right here and the message is right here. So these parts are really easy. So let's just say fcl.arg, pass in the sig. This is a t.string. And the next one is a fcl.arg message, which is a t.string again, and we're good to go. Now this function returns a boolean, so in order to actually get that boolean, we have to decode this script result, and then we can console.log the response here, which is coming from this script right here. So if we run node main.js, let's see what happens. So await is only valid in async function, so I forgot to make do stuff in async function. So let's just make that happen, because we're cool. Oh, oops, because it's an arrow function, so I have to put that right here. My bad. Okay, boom, async. Now let's run this again. And we get unknown member. Okay, so let's see what mistake I made. So if we go back to our script here, that should... Oh, okay, yes. So I know the reason for that. The reason for that is because in our script, when you say let account key equals account.keys.get, this get function returns an optional. So in order to do that, we actually have to unwrap this optional. This is just Cadence stuff, but we have to unwrap this optional and say, like this key index does not exist, in this account, right? So just like that. So that way we unwrap the optional and now it should be good to go. But of course we have to copy and paste this change into our, code over here as well. So if I run node main.js again, okay, awesome. So here's the message, here's the signature, and we get false. So why is it that, we're getting false here? It's saying, hey, for some reason, it thinks that this message or this signature was not produced by this account and this specific message with this key index. So what's the problem here? Well, the problem here is this domain tag. It's expecting when you use this verify function on chain, it's actually expecting that the domain tag was prepended onto the message itself. Now, when you're doing this with like authorization functions or a transaction message, or you're signing a transaction, which by the way, I've done a whole video on that separately, this is already done for you. It already prepends it onto the message. However, in our case, because we're signing a custom message here, we actually have to prepend the message ourselves. So in order to do that, let's go back to the GitHub again, go to main.js, and go to these two functions right here. And again, I hate copy and pasting code, but I think it's necessary here because you don't want to mess this part up. So copy paste the user domain tag and the right padded hex buffer, just like this, and go ahead and paste it right below the hash function. Now, this is going to be used so that down here, when we sign our message, we're going to also sign the user domain tag plus the message. So the user domain tag is coming from right here. You can see the tag itself is flow v0.0-user, which is what the tag is right here as well. And that's going to be used to, we're going to pass in, we're going to sign the domain tag plus the message just like that. So now it's actually going to say, now it's going to think that it's correct, hopefully. So if we run node main.js, now it's going to say true. Yay. So for the record, that tripped me up for maybe like 72 hours straight. So you're welcome for solving that and not, for, helping you not go down that rabbit hole. But anyway, this is it. So I hope that was helpful. And you know what? Now that we're done with the video, let me just do a quick recap. So what's really going on here is if we look back at our, at our image again, where we have some account with a public and private key pair. The public key is right here, and the private key is what we're using to actually sign the message right here, right? Now remember, messages can only be signed with a private key. So, when something is signed, that some account actually, did it with their private key. And we signed the message. Jacob is cool. We had to convert it to a hex though, right? We signed it with our private key, which produced a signature. And then to verify that signature, we said, okay, we need to, first of all, know what key we used, which is, key index 0. So we need to use this one. And that is used in our script to actually get the public key, right? That's what these two lines are doing. And then once we have the public key, then we can, if we go back to our script, once we have the public key, we pass in the signature and the message, which is what I'm telling you right here, public key.verify the message and the signature. And then the domain tag and the hash algorithm right here. And that's going to verify that this account address is the one that signed this specific message with this specific key that produced this signature. So hope that was helpful. See you in the next one. Peace out.